Hello and welcome to this fourth session of the Fireside Chats from SGS. My name is Willy Fabricius, and I'm the Global Head for Strategy and Business Development in Business Assurance. I would like to say good morning for our friends in the United States and Canada and Mexico. And good afternoon for our friends in Europe, and good evening for India and Asia. Greetings from the RSA conference in San Francisco. Today we have a very interesting panel, and today we will discuss trustworthiness AI, and in particular we are talking about transparency and explainability. So that said, I would like to introduce today's participants. First, we go with Tomislav. Tomislav, would you mind to introduce yourself a little bit, please?
Hi, thank you very much, Willy, and hi, everyone. So I'm Tomislav. I'm lead innovation technologies SGS, where I'm basically analyzing the impact and analyzing the impact of emerging technologies to our customers and to our company. So I have a deep background in cybersecurity and working for over 15 years there in various roles. Started from a PhD in cryptography and ended up in all kinds of different positions with regards to cybersecurity. Then I started to look into the security of AI systems a little bit over 2 years ago. And this has been broadened more into all other aspects of the trustworthiness of AI, which is my main topic at SGS, where I'm really looking what trustworthiness of AI means, how our customers are dealing with it, and how we as a company, as a tech company, can assess the trustworthiness of different AI systems.
Tomislav, thank you very much. Ilya, you are next. Please be so kind to tell us something about yourself. And you're on mute.
So again, I'm Ilya Shimich. I'm a researcher at the Novo Center in Graz, Austria. So I'm originally from Bosnia and Herzegovina, but I came to Graz, Austria to study computer science, where I did my bachelor's and master's here. I'm currently now at the end of my PhD. In my research, I focus on methods for explaining and understanding black box AI models, in particular for time series data. And I'm mostly interested in investigating how explainability could help in verifying, improving, and extracting knowledge from black box models.
Excellent. Thank you. And Dominic.
Yeah, hello everyone. Thanks for the introduction. So as Ilya, I'm working at the Novo Center. I'm already working at the Novo Center since 2012. So we are a research center for Trustworthy AI. This is also my main field of research. And at the Novo Center, I'm the research area manager of the FAIR AI group. So mostly dealing with AI-based systems and issues around fairness, biases, but also transparency is important here. I did my PhD at Graz University of Technology on the topic of enhancing the transparency of AI-based recommender systems using cognitive modeling techniques and theories from psychology. So I also hope that I can talk about this a bit more than in the following. Thank you.
Excellent. Thank you so much. So my first question is, what is transparency in AI, and how does this relate to explainability? Ilya, want to go ahead with that?
Yeah, sure. So transparency and explainability are two closely related but distinct concepts. So transparency is the general understandability of an AI system. So it goes beyond the AI itself. So on one hand, it means how understandable is the model itself. So can we pry into it and look into it and understand how it makes its decisions and for what reasons. But it also encompasses more than the AI itself. So for example, what data has been used to train the model? Is the data accessible to everyone? Is the model itself open source? How was the model trained? So all these things are necessary to know if we want to ensure that the model is transparent. Explainability, on the other hand, is the ability of an AI to provide understandable explanations for its decisions and actions. And this understandable is kind of the key point here, because the explanations must be understandable to the person consuming the explanation. So, for example, a person who's developing models may want to look inside the model, kind of really get an understanding how it functions from the inside, while a person who got the rejection on a bank loan might just want to know what they have to improve to get the loan accepted. So explainability is a way to achieve transparency.
Now you're mute, Willy.
Yes, and I got this flash saying you are muted. I think I get it. I wanted to say. So why is transparency and explainability in AI so important? Dominic?
Yeah, thanks for the question. So I think I can now nicely build on what Ilya told us. So explainability and transparency is one of these key requirements for Trustworthy AI that we got from definitions by the European Commission or also from other institutes, and also different researchers have brought up similar definitions on what AI should fulfill in order to be deemed trustworthy. So there are things like fairness, privacy, robustness, accountability, but also transparency and explainability as one key, mostly technical requirement for Trustworthy AI. So if we want to have a Trustworthy AI system, it needs to be transparent and explainable. So this is the first thing. This is also now brought up again by the European Commission in the AI Act, where especially for high-risk applications of AI. So Ilya mentioned this use case in the financial domain, if you get a loan or not. So this is typically a high-risk application where things are on stake and human lives are affected in some way. So for these systems, transparency needs to be taken into account. So people need to know why a specific decision was made, and also how the inner workings of the AI system look like. So, but also not only from the legal requirements, it's important, and not only for businesses, but also for research. So if we think of the reproducibility of a research result, here also transparency is a key requirement. So if you don't know how the AI model was trained, which data was used, how the model was evaluated, to which baselines it was compared to, we cannot trust the findings of the researchers, or we cannot trust that this model is maybe better than another model. So also, if you want to reproduce or build on a specific model and a specific research result with respect to AI, it needs to be transparent. We need to understand it. And here just read a quite interesting paper where they assess the reproducibility or the transparency of very good papers only published at top-tier AI and machine learning conferences and journals, and they found that only 1/3 of these studies are reproducible, mostly due to the lack of transparency. So this also shows us that a lot of things need to be done in order to enhance transparency and explainability.
Yep. Yeah, that reminds me a little bit of many years ago when I was working in quality management. There was the concept of repeatability and reproducibility, so that the test results were well repeatable and could be reproduced. And that was a key question in terms of the measurement system. And obviously, I can see the very same happening with regard to AI. You know, an old-fashioned cup, inner diameter, outer diameter, I measure it with a caliper or vernier. And that in itself is already that seems to be pretty simple, right? But when I now have 20 operators doing that, I will get approximately 21 different results. And that is obviously a serious question, even for a simple test like that. I can see that for AI, that might be even getting way more complicated than that. But anyway, so how does the lack of transparency and in AI systems pose a risk for business operations, Tomislav?
I mean, first of all, it will be a trust issue, right? So let's if nobody understands how your AI system works and how it's coming to its decision, then it's less becoming trusted. The second part is the regulatory aspect, right? Soon we have the UI Act, which will be enforced in 2 years. For high-risk systems, you will have to fulfill certain regulatory aspects. So just for compliance reason, you need to be as transparent as basically the regulation will ask for it. On a trust side, back again, and especially I would say in the use case of healthcare systems. So if you use AI systems in a healthcare environment, where usually, let's say you have a decision support system with basically the doctor is using some form of AI system which helps him in diagnosis and helps him, to interpret images and maybe see diseases or gets indication where diseases might be on an MRI scan, for example, right? The doctor needs to understand ideally how the AI system works. If he takes this as a very important factor in his final diagnosis, then he needs to understand how this AI system comes to it, is so that he also can, to some extent, verify if there's really a true indication what the AI system tells him. In order that actually the end users are accepting those kind of systems, you need to have a certain level of transparency and explainability so that people get an idea, a good idea about how the things are actually working. That's especially for the healthcare system, but in other areas, it's quite similar. And for now, looking at it from a TIC perspective a little bit, and a little bit on what top of you just said before, now if you're running test labs, our results need to be repeatable and reproducible. And when we started testing AI systems, which are not that easy to make those tests in such a way that everything is repeatable and reproducible, it also has the challenges for the TIC industry itself and for the test labs running AI system tests. So we really need to be careful, and when we are creating test procedures, that we still stick to our requirements that everything we are doing is reproducible and repeatable.
Yeah, I'm wondering, once we are using AI systems in our labs, how we are going to calibrate them. And what kind of national or international standard will be used to ensure traceability back to them for the calibration process?
Exactly. Yeah.
That will be an interesting discussion. I can see that already. But the good news is, during my recent participation at the SC42 meeting in Seoul, South Korea, yes, this kind of discussions happened even yes on the ISO committee levels. So I'm very confident that in the next couple of years we will see even ISO standards for that, and that is very encouraging indeed. So the next question is along the line: how can we ensure that AI systems are actually transparent? Dominic?
Yeah, thanks for this question. So I think in general there could be 3 ways to do this. The first one is more on the documentation level. So we need to have at least some good documentation on how the model was trained, how the hyperparameters were optimized, which data was used, training data, but also test data. Also, the evaluation is important. So as mentioned before, we also need to know which baselines were used. So this process, so a good documentation is key. Also, if we want to then validate and certify AI, we need this anyway. So the documentation, then more on the technical level, I think there are a lot of methods now from the explainable AI, this XAI field, on post-hoc explanations. So once we already have the model, how can we explain the decisions that the model did. I'm pretty sure that Ilya can then talk about hours about this, maybe later on. So I won't go into these details now. So documentation, first one, explainable AI methods, this post-hoc explanation, and the third thing where I'm mostly interested in my research is to build transparent models by design, so that we try to design a model in a way that it's understandable by design. So I mentioned beforehand in my PhD, I used models from human memory theory, from cognitive psychology, to build AI-based recommendation systems. So here we used really equations and models that come from long-standing theory. So we know how they work, and if we can put them into an algorithm and use data in order to train this algorithm, then we should always be sure why a specific decision was made. So we can always trace it back because of these rules that we encoded. But of course, this is sometimes not that easy. But it's a quite elegant way to make a system transparent by design. And there's now also this research field on physics-informed machine learning, and they try to do similar things. So to build on theories and rules from physics in order to make machine learning models. So I think these are the three general strands of things that we can do, but it's not really clear which one is best. It always depends on the use case, and maybe it's a combination.
Excellent.
I would have a follow-up question here. So can we a little bit distinguish between large language models, so all the ChatGPTs in the world, and the transparency and explainability around that, and narrow AI models, so the classical AI models we are actually used to use in all kinds of applications. Do you see different challenges for those kind of things with regards to transparency and explainability?
So for large language models, there's, as far as I know, there's just a little research available on how transparency there can be measured. I mean, there are billions of parameters, of layers in these deep transformer-based deep learning models. So I don't think that someone has an idea of how this works.
So maybe I can jump into that as well.
Yeah.
I mean, this is a very typical division in explainable AI, kind of between white box models, so kind of AI which is explainable by itself, where you can just observe the model internals, understand it, and explaining black box models, which have like these billions and billions of parameters. And for that, it's always the question, what do you want to explain? What does the explanation has to contain? And for whom is the explanation? And basically, we would have to first have answers to these questions so that we know how to approach this topic of generating an appropriate explanation, or how to achieve transparency in that regard. But in general, this topic of explanations for large language models, or in general generative AI, is currently a kind of a hot topic, and there are still many open challenges regarding that.
Excellent. So Dominic, you mentioned let's say the keywords that triggered a thought on my side, and that was obviously certification of AI systems. How far away are we from that? When do you expect that we are able to certify an AI system? And what kind of criteria?
Yeah, I think so. I think the criteria, so I think there are different possibilities on how we can build this criteria. So I already mentioned the 7 dimensions we have from the European Commission for Trustworthy AI. So we can definitely start with them. So we can try on how to evaluate each of these different fields. And based on this, probably we can then inform an auditor on if this can be certified or not. So I think this could be one starting point, but I think there's a long road to go on AI certification, especially since AI-based systems are evolving systems, they are learning systems. So if we certify them today, then they are retrained on different data, in different use cases. It's then the question, do we need to certify them again? How long are they certified? So I think there's still quite a lot of open questions here.
Yes, yes. Well, the good news is that at least from a governance perspective, from a management system perspective, we do have already methodologies to ensure that the foundation is there. So certification to ISO 42001 would be obviously a very good step to make sure that the governance system, the management system, is already in place. And maybe I'm biased because obviously management systems is my background, and I think that also would lead to at least a base layer of trustworthiness and transparency, because then there is some kind of methodology that the organization is able to demonstrate, well, we followed this kind of steps, and we have this kind of methodologies in place to identify risks and the impact. So I also believe that this might be a very important first step towards certification of the actual AI system. But anyway, what are methods that can be used to explain AI, Ilya?
Great question. I will not take hours to answer that question, Dominic, but I could talk.
No, you have 2 seconds.
Okay. So basically, there are many methods that can be used to explain AI, and basically they vary depending on the used model that we have, the access to it, and what we want to understand. So for example, we can divide explanation methods depending on the used type of model between white box and black box models. So as I mentioned previously, there's white box models which are treated as kind of inherently interpretable or understandable. So these are models where we can look inside and in theory understand how the model makes its decisions. But in practice, it's usually in a way that we still need some other methods to visualize how the model internals actually look like. And as you can imagine, with rising complexity of the model, even if we can look inside it, we cannot comprehend what is going on. Black box models, on the other hand, are kind of these large, complex models where we just cannot understand what's going on in there, and we need, in general, we need explanation methods. Another division would be related to the scope of the explanation. So kind of either we have global and local explanations. So global explanation methods explain the model as a whole, kind of the general decision-making approaches to detect a certain class, for example. So what are the data aspects or data properties for a model to identify a certain disease, for example? Local explanations, on the other hand, explain a single prediction. So if John Doe applies for a loan and gets a rejection, he doesn't want to know how the model in general works, but he just wants to know the single things that he has to improve to get this loan approved. Another division would be kind of regarding to the access or to the model. So we have kind of these model-specific and model-agnostic explanation methods. So the specific ones are kind of tailored to a specific group of models, for neural networks. And model-agnostic methods, they work on any kind of model. So they basically work kind of by just probing the model from the outside and seeing how it affects the model's predictions. So as you can see, we have here many different approaches to kind of explain AI, and explanations that then come in different formats. So we can receive an explanation, for example, as a set of rules. There are also explanation methods which provide feature importances, which kind of explain a model prediction by highlighting which parts in the input specifically were important for the model to make a prediction. There are then something called counterfactual explanations, which basically say what do you need to change so in the input so that the model changes its prediction. And we also can visualize the model internals. So this is something more of for model developers. So as you can see, there are many, many considerations that will be taken into account when we want to actually explain AI.
Fascinating. Fascinating. So let's move a little bit into the legal domain, into the regulatory domain. Um, how do regulations, in particular in Europe, but also, of course, in other regions of the world, see transparency? Tomislav?
Yeah, so we heard from Ilya and Dominic basically that those two areas of transparency. We have the explainability part, that's what Ilya just describing, where really try to understand the decisions of a specific AI model, right? And then we have the transparency around that. So how a certain AI system and model has been built. And that can basically start from design decision of the AI model to training data to model, how you train the model, how you structure the model, what's the intended use case of the model, what's the accuracy of the model, and so on. And for example, the EU AI Act is focusing a lot of those documentation stuff. So document everything, as Dominic was saying before, so that everybody can understand, to read the documentation, what the decision was to make the model, what kind of architecture used for the model, what is the training data, where's the training data coming from, how is the quality of the training data, how you take care of making sure that the system is fair, and so on and so on. So a lot of the transparency requirements in regulation is about documenting basically every step of the AI lifecycle, so that when you're seeing some decisions or when you use or put in use an AI system, you can have a good idea about what this is about, how it has been created, and what kind of risks you're facing with it, right? And then there's the specific.
Sorry for interrupting.
Go ahead.
Sorry for interrupting, but that sounds like a governance system again.
Exactly.
Like a management system.
If you have an AI management system, which ideally complies to ISO 42001, right, you would tick the box basically, because the management system test, you should exactly do that and document everything and have a structured approach on developing an AI system, also to manage the risk associated with that, right? And then the explainability part, which, as we also heard from Ilya, is still heavily under research. So like we have models where it works very well. We have some other areas in AI research where still a lot of work needs to be done. And there's no basically saying in any of the regulation that you have to be a fully explainable system, because that's just not feasible yet for every use case. For specific use cases, you should basically do what's as much as possible in this area. The NIST risk management framework, for example, which is not a regulation per se, but basically a standard published by NIST, they are basically distinguishing that a little bit by having accountability and transparency together as a requirement, and that's really about what we were just talking. And they have explainability and interpretability as a second requirement, where they're really focusing on the models and understanding of what has been done. So for the regulation side, it's really a lot about documentation, making everything clear to the outside what you have done, so that we can actually assess the risk properly. I would summarize it that way.
And yes, there's not just the component of documenting where things come from and how things have been developed, but also there is this concept of logging activities.
Exactly.
And logging, so that means really creating records, why certain things or what has been done. And once again, there's a very intensive working group at ISO working on this domain. So I would expect that we see some very interesting international standards coming out of that working group in the very near future, which will help us with regard to those requirements related to logging of activities. But please go ahead.
Yeah, that's actually a very important point, right? It sounds a little bit like, logging, what's the big deal of it? But actually, it is not that easy. And if you look at just from now, we were just talking about regulation, right? The UI specifically talks about logging, and the background, a little bit of that, one side of the background is when something happens, so your AI system makes a decision and it was a false decision, a wrong prediction, whatever, you kind of would like to backtrace what happened. And for that, you need to log important events, right? So this is really a key requirement in order to have a fully transparent system. And good to hear that standards are in the making to help companies complying with all those regulations.
Yeah, I mean, that reminds me a little bit of the time when I didn't have gray hair and was developing software, post-mortem analytics and post-mortem debugging on a regular basis, the issue was that, well, it just crashed, but there was no log available. There was no crash data available. And then the next question was obviously, can we repeat it? No, we couldn't. And then 2 days later, it happened again. And that is, in a certain way, a repeatable issue. And I think that going forward, it only will be emphasized and amplified that this is an absolutely crucial aspect of, AI transparency and explainability. But so are there cases where transparency and explainability is not needed? Would that be also a possibility? Dominic?
Yeah, maybe,
You address
yeah.
that?
So I think transparency is always good. I think we, as what we heard so far, we can agree on this. Transparency is always good. But so for this high risk areas, high risk AI applications, we also need it. We need it according to the AI Act and these regulations. For low risk applications, for example, if you think of music recommendations in Spotify, so AI-based decisions that don't have that big of an impact, it's not really needed, but of course it's beneficial. So if you still provide it with some short explanation on why this track was recommended, then probably the user, or there's a higher probability that the user will consume it, click on it. So, but of course, what could also happen is that the explanations are not tailored to the user. So I think Ilya shortly mentioned this. So it could be that the explanations are way too complex or too long, so that the user needs to deal with an even bigger information overload problem, and then this explanation could backfire. So they could have a negative effect, and the user won't click this. So you always need to have this trade-off between information overload, how the explanations are personalized, and what to show, more or less. There are also other trade-offs with respect to transparency and explainability that we should think of. So Ilya mentioned these counterfactual explanations, so that you tell the user what should be changed. And of course, someone could use this information in order to make attacks on the model. So could try to trick the model. So there are trade-offs between explainability and robustness, probably also between explainability and privacy, because within these explanations, you could leak some sensitive information of the user that the user probably do not want the system to make public via explanations. And typically, if you make a system explainable, it could be that this also goes on cost of the accuracy. So that you don't have this big black box model, so you have a white box model. It's explainable, it's understandable, but you decrease the accuracy. So we see we have different trade-offs here. So it's really hard to answer what's the right way to go, more for transparency, explainability, or more for the other objective. This really depends on the use case.
And let's not forget the dimension of confidentiality. So you mentioned privacy, but confidentiality could be a broader perspective. I mean, for example, yesterday here at the RSA conference, there was the example. Let's say we are using an AI system for detection of vulnerabilities in IT systems. Okay. So how do we train it? Well, we are obviously training it with existing IT systems and the existing vulnerabilities. And potentially that has also the name of the organizations whose IT systems are being monitored. Well, if that information is in the training set, then it's in the AI knowledge base. That means also adversarial attacks could happen and say, tell me what are the vulnerabilities of organization XYZ. We've got a problem here. So it really starts with the concept and the design of the system, so that certain data might be not even in the training set intentionally for the purpose of later on protecting privacy and confidentiality. So how can transparency and explainability be measured? Is there something like measurability of transparency and explainability?
So I guess I'll take that one. The answer is basically through various kinds of evaluations and benchmarks. Specifically, so it depends always what we exactly want to measure. So generally, we can divide these kind of evaluations between if there are humans involved, or do we test the correctness of the explainability method. So in the case that we kind of have real humans involved, we have this kind of application and human-grounded evaluations where we have real humans, and either the concrete tasks where explainability is used or some kind of proxy tasks. And in these cases, we measure basically the usefulness and plausibility and usability of the explanation methods. Through functionally grounded evaluations, or which are basically benchmarks, we don't have humans, and we have some kind of proxy tasks. And in these cases, we measure the correctness of the explainability methods themselves. And there are many different things that can be measured in this case, which provide us a concrete number that we can then use to tout how explainable our model is. So for example, concretely for explanation methods, we can measure faithfulness. So basically it measures how accurately an explanation identifies features which are actually driving the model prediction. So if you would take a look at different explanation methods, they sometimes provide explanations which kind of are in disagreement. So what we also can measure is the robustness of the explanations themselves. So which means if we just alter the input a little bit, will the explanation also be changed just a bit, or will it kind of become a complete jumble? So this is also kind of a so we can kind of counteract these kind of adversarial attacks on the explanation method itself. And what also can be measured in this context is complexity of the explanation method, which in general says that the more compact or less complex the explanation method is, the more understandable it is. So this is kind of very intuitive. So again, it depends on what we actually want to measure, but there are various methods and metrics which can be used to measure these different kinds of aspects of explainability.
Okay. So are there any tools available to explain this? And if yes, are they freely available, or are they still under development? Any idea in this area?
I will focus on the freely available and open source methods and libraries, since I use them. And there are actually many available, so the community is actually quite active. So for example, for PyTorch developers, there's a library called Captain, which is a very popular framework for post-hoc local explanations. So for generating explanations on already trained models. For TensorFlow, there is the Investigate library, which is also open source. It's on GitHub. They're very usable. They're also generally for Python, the Shep and Line libraries, which provide their respective model agnostic explanation methods. For R, there's Dalek or Dalex. Not sure how it's pronounced correctly, since I just used it in the reading. And there's also, for example, a library which we can use to evaluate these explanation methods, which is called Quantus. So all in all, there are quite many libraries actually which are freely available and open source, which can be used either to explain AI, or which can be even used to kind of measure the quality of the explanations.
Wow, this is cool. So from your point of view, and that's a question for all three of you. Where do you see the biggest challenge in this field?
Ooh,
Oh, now
Well,
everyone
let's
is quiet.
start.
it's hard.
It's yours. Let me start. I think one of the biggest challenges is the models are getting bigger, so it fits quite well to the questions. The models get more bigger and bigger and more intransparent, basically, and the harder it will basically get to understand what the AI model does, especially obviously in deep learning, where we have very numerous layers of neural networks. It's getting more and more complicated and more difficult to actually explain what it does. And if at some point in time we're not really understanding, like in large language models, it's often the case that we're really understanding how we came to the result. That's kind of a little bit of a scary thought from a human nature perspective.
So I would also
Yeah.
jump in shortly. I mean, it has been mentioned quite a few times already, is the lack of standardization. So there's so many definitions, lack of definitions. For example, what exactly entails concretely transparency? So there are slight variations between who is defining transparency. Everybody knows generally what it is, but there's no like clear standardization which everyone can kind of hold on to.
That's true. Maybe what I can add. So beforehand, I mentioned these different trade-offs. So this is especially from a research perspective interesting. So finding good trade-offs between explainability, transparency, and accuracy, privacy, confidentiality, as we heard, and also robustness. So working on these different trade-offs between trustworthy AI dimensions. I think this is a general issue here. And what we also heard. So reproducibility, repeatability is very often a problem. So as I mentioned, only 1/3 of the very good AI papers are reproducible, which is a problem. So how can we validate or certify it if we cannot reproduce it, if we don't understand what's happening?
Right.
So there is a lot of things that needs to be done, that we need to work on. So I think.
And
these are the main
circling
challenges.
back to the concept of certifying an AI, I think one aspect is really that is crucial to consider is the application of the AI. So the very same AI system could potentially be used in various domains, and depending upon what domain it's being used in, what legal environment it's being used in, it could have different criteria for acceptance or rejection. And that obviously is a fundamental concept of certification, because certified according to what? Certified for what? And if that is not clearly defined, then we've got an issue. Respectively, well, that AI system might be certified for this domain, but not certified for that domain, for whatever reason. That said, we are reaching the end of our discussion. And I really would like to thank Ilya and Tomislav and Dominic. Any last thoughts? Any last minute, last second ideas for the benefit of our audience?
Maybe what I would like to see more, apart from the explainable AI research field, which I think is really involving, is more work on using really theory for building transparent models. So using all the theories that we already have available from physics, from psychology, and so on, in order to make models, to create white box models that are understandable but also accurate. But this is quite hard to achieve. But this I would like to see more.
Yes, yeah, and again, that was one of the discussions we had at the SC42 meeting in terms of going back to the toolbox of tools we have already. And yes,
Exactly.
modify those tools as appropriate, but not reinventing the wheel. I mean, in the last couple of thousands of years, we have developed tools. And those tools are obviously coming from mechanical engineering, electrical engineering, computer science, blah, blah, blah. But those tools potentially could be adapted for this domain as well. Very good comment. Tomislav, last and final statement.
Maybe give me another minute, because when we are talking about transparency and explainability, I kind of was, and one thing it was missing was the clever Hans effect, which I really
Okay.
like, in this context. So for the audience, so the clever Hans effect is basically based on a story of a very smart horse in the early 20th century in Germany, which will believe that the horse can basically perform arithmetics and understand music and stuff like that, right? And so what it was doing, they were basically doing a show where the owner of the horse was giving a simple calculation, what's 2 + 2, right? And the owner would basically on a board will show different answers, right? And when the pointer was at the right answer, the horse would basically tap with his shoe on the floor, right? And so why everybody was amazed how really smart horse, right? Can compute and do arithmetics. But later they found out that it's not that smart. But we are probably put too much thought on it. But what actually happens, the horse reacted on involuntary body language of the person who was pointing the pointer to the right answer, and also to the audience. There were obviously subtle signals which were different to the wrong answers, and that's where the horse was basically reacting. What does this to do with AI and explainability? It's very simple. We have that here. We have the clever Hans effect here as well. So there was obviously some good example was huge image database everybody was using for benchmarking the image classification algorithms. And there was, for example, very good models where were able to detect boats on every picture. Awesome, was very great, functioned very, very well. But then explainability started to being a thing, and people started to try to understand why is it detecting boats so well. And then they found out that every image of the boat in the training data was on water. So what it actually detected was water. And so basically what the AI model was thought, we were thinking it detects boats very well, but in fact it was only detecting very large blue areas in the picture, and then it was saying that it's water. And now, not a link to horses back, it was very good at detecting horses, which is also very interesting. The reason for that was that the images were used for training were coming from a huge database, and every single image has a watermark. So what was actually detecting was the same watermark. And if you see the watermark, okay, then it's definitely a horse. So that's why it's important that we actually understand what the AI model is doing, because we kind of start to believe that they're doing more than we actually thinking it does.
Yeah, this is the correlation versus causality
Exactly.
dilemma.
Good.
Nice.
Ilya?
Yes, so I would like to actually build upon Tomislav's comment. It's to go beyond a single explanation, so that we don't only explain and model prediction, but that we kind of increases human in the loop, basically. That humans are provided an explanation, and then can interact with it and provide it back to the model, so that the model can also learn from domain knowledge. Because in this specific case with the watermark, if you put the watermark on an image of a car, the model was also sure, like 100% this is a horse. But it would be nice, for example, to be able to observe these kind of decisions, and then the human basically can select a region, like the watermark, and say, okay, ignore that part and retrain. And basically, that it's more of a back and forth. So that the model is trained, it provides explanations to the user can provide feedback to it, and so on, so that we, on one hand, get better performing models, but also that they are right for the right reasons and not right for the wrong reasons.
Excellent. So, conscious of time, gentlemen, thank you very, very much. And this was a great session again. So, for the benefit of the audience, there is, as usual, a white paper you might be interested in downloading from sgs.com. The particulars are here on this slide. Please feel free to go to our website and download not just this white paper, but the other white papers coming from this series of fireside chats. And our next fireside chat is scheduled for June the 11th, and it's titled Trustworthy AI, Human Agency and Oversight. After all, At the end of the day, we cannot rely just on the AI's decision. There needs to be some kind of oversight by people. There needs to be some kind of ability to make sure that indeed these AI systems are not producing any harms for the human society. That said, thank you very, very much for your attendance. I hope you enjoyed this fireside chat as much as I did, and looking forward to welcome you again on June the 11th for our next session. Take care and bye-bye.